Right now, someone is sitting in a corporate lobby. They look like they're texting. Security cameras are watching them. The building's network defenses are humming along, designed to catch exactly this kind of threat. But they won't catch anything, because the weapon they're holding fits in their pocket and it's completely invisible. This wasn't a hypothetical scenario. In 2023, a Fortune 500 company discovered their network had been compromised. The breach happened in broad daylight. The attacker spent 40 minutes in their lobby. They sat near the main entrance, blended perfectly with employees and visitors, and executed a complete network reconnaissance. Security footage shows everything, but the footage shows nothing that looks like a threat. For 2 decades, we've known what corporate espionage looks like. A van parked outside with antennas, a laptop glowing in someone's lap, visible equipment, obvious behavior, all the things security teams are trained to detect. That entire profile just became obsolete, and the tool responsible for erasing it is sitting in your pocket right now. It's an Android app, free to download, no special permissions required. It has 10 million users. Half of them have no idea what they actually have. The other half understand they're carrying something that shouldn't exist. And for the past 4 years, Google has been fighting a silent war to make it disappear. This is the story of how the most powerful hacking tools in the world became completely invisible. To understand why this matters, you need to understand what you're up against. For the last 20 years, there's been one undisputed standard in penetration testing, one fortress, one name that every serious hacker, every security researcher, every government agency knows: Kali Linux. Kali isn't just a tool. It's a complete operating system built exclusively for offensive security. It comes pre-installed with over 600 hacking tools. Everything from network scanners that map entire corporate infrastructures to exploitation frameworks that can break into systems in seconds. It's the result of decades of development by a global community of security experts. It's what the NSA uses. It's what Fortune 500 companies hire penetration testers to use against their own networks. To use Kali properly, you need years of training. You need to understand networking protocols, system architecture, scripting languages, and the psychology of how security systems think. You need dedicated hardware. You need a laptop. You need to be visible. You need to be obvious. And that visibility has always been part of the deal. If you wanted real power, real capability, you paid the price of exposure. Kali represented the ceiling, the absolute peak of what offensive capability looked like. It was heavy. It was complicated. It required expertise. It required hardware. It required you to be noticed. And for 2 decades, that was simply how things worked. You wanted to test a network, you brought a laptop. You brought tools. You brought yourself. Then something unexpected happened. Someone realized that the most powerful computer in the world wasn't sitting on a desk. It was in everyone's pocket. Here's the problem with that idea. Android was specifically designed to prevent it. When Google built Android, they weren't building a platform for power users or developers. They were building a locked garden for consumers. Every app runs inside something called a sandbox. Think of it like a prison cell. Each app gets its own isolated space. It can't talk to other apps. It can't see what other apps are doing. It can't access the raw hardware. It can't see the network traffic flowing through the device. It's locked down. On top of that, Google added SE Linux, a security framework that restricts even deeper. Apps can't access the directories where all the systems running processes live. They can't read raw memory. They can't execute their own binaries. Every single thing you might want to do to turn a phone into a hacking device is explicitly forbidden by the operating system itself. This wasn't an accident. This was intentional architecture. Google looked at what made desktop computers powerful and dangerous, and then systematically removed all of it from phones. They wanted phones to be safe, predictable, profitable, consumer devices that couldn't be repurposed into weapons. And it worked. For years, the mobile world stayed locked down. Hackers and security researchers had to accept the limitation. If you wanted real power, you needed a laptop. If you wanted a phone, you accepted being crippled. There was no middle ground. Android's prison seemed unbreakable. But there was one thing Google didn't account for. One thing they couldn't have anticipated. Something hiding in plain sight, buried so deep in Android's foundation that nobody thought to look for it. Android is built on Linux. This is the foundation, the kernel, the core of everything. Google took the Linux operating system and wrapped it in their own consumer-friendly interface, but underneath all the touchscreens and app stores, it's still Linux. Raw, powerful, unrestricted Linux. In 2015, a developer named Frederick Fornwall realized something. If Android is Linux, then somewhere inside that locked phone, there's a Linux environment waiting to be accessed. And if you couldn't access the system-level Linux, maybe you could create your own private Linux installation living inside an app's data directory. Your own isolated operating system, running natively on the phone's ARM processor, completely separate from Google's restrictions. He created Termux. It's remarkably simple in concept. The app compiles standard Linux packages, the same tools you'd find on a desktop Linux system, but it compiles them to run inside the app's own private sandbox. It's not breaking Android's security model. It's working within it. The app has permission to write files to its own data directory. Those files can be executable. And if they're executable and they're native ARM binaries, then the processor will run them. Suddenly, a phone could run a complete Linux terminal, a full command line environment. And once you have that, everything becomes possible. You can install network scanning tools. You can deploy exploitation frameworks. You can run Python scripts. You can access remote servers. You can manage databases. You can do everything that Kali Linux does, but you're doing it on a device that fits in your pocket. What Frederick created wasn't a hack. It was an elegant exploitation of Android's own genetic code against itself. He didn't break the rules. He found the loophole that was hiding inside them all along. By 2018, Termux had evolved into something far larger than a simple terminal emulator. An entire ecosystem emerged around it. Developers started packaging Metasploit, the complete exploitation framework, directly into Termux. Nmap, the industry standard for network reconnaissance, was compiled to run natively. Python environments appeared, SQL databases, custom payload generators, everything you'd find in Kali Linux, adapted and optimized to run on mobile hardware. The implications were staggering. A penetration tester could now run a complete security audit from their phone. They could map a corporate network, identify vulnerable systems, and launch exploits, all from a device that weighed less than a sandwich. They could do it during a lunch break. They could do it while sitting in a lobby. They could do it while standing next to someone and appearing to check their email. By 2019, Termux had been downloaded 10 million times. 10 million devices were now carrying the same offensive capability that previously required a laptop, years of training, and obvious, visible equipment. And here's the remarkable part. It required zero special permissions. Android's permission system is designed to warn users when apps access sensitive features. Termux didn't need any of that. It was just writing files to its own directory and executing them. Completely invisible in the permission list. The tool wasn't just powerful, it was accessible. Anyone could download it. Anyone could learn it. The barrier to entry had collapsed. What was once the exclusive domain of government agencies and professional security firms was now available to anyone with a smartphone and an internet connection. Google was about to discover this ecosystem existed, and they were not going to be happy about it. In 2019, Google made a decision. Termux was removed from the Google Play Store without warning. No announcement, no explanation, just gone. The official reason given was vague, unacceptable risk. That's all Google said. That's all they were willing to admit. The real story was far more complicated. Google couldn't publicly explain what Termux actually did without admitting something uncomfortable. There was a fundamental vulnerability in Android's architecture, a flaw that allowed users to bypass the entire security model Google had built. A flaw that, once weaponized, made the phone invisible as a threat vector. If Google explained that openly, it would have triggered panic. Enterprise customers would have demanded answers. Security experts would have questioned whether Android was safe at all. So Google did what large companies do when they face an uncomfortable truth. They acted quietly. They removed the tool from their official store and hoped the problem would go away. It didn't. Users simply migrated to F-Droid, an independent app store outside Google's control. The community didn't scatter. It reorganized. It went deeper underground. And in doing so, it became harder to track, harder to control, and arguably stronger. But Google wasn't finished. In 2022, with the release of Android 12, they introduced something called the Phantom Process Killer. It's a background service that automatically hunts down and terminates any application spawning more than 32 background processes. This was a direct, targeted attack on tools like Termux, network scanning scripts, automation frameworks. Anything that spawned multiple parallel processes would randomly crash. Google was escalating, and the community was about to escalate right back. When Google introduced the Phantom Process Killer, the community didn't panic. They adapted. They discovered that Android's developer tools, specifically ADB or Android Debug Bridge, could be run wirelessly over a local network. Using ADB, users could access deeper system settings and disable Google's background process restrictions entirely. It was crude. It required technical knowledge. But it worked because ADB is a developer tool built into Android itself, designed to let programmers test their own applications. Google couldn't block it without crippling the entire Android development ecosystem. The forced migration to F-Droid had an unexpected consequence. It unified the community. Users who downloaded from F-Droid were already demonstrating a commitment to capability over convenience. They'd already made the choice to step outside Google's ecosystem. That group became tighter, more dedicated, more willing to learn workarounds. The tool didn't weaken when Google pushed it underground. It evolved. But the community paid a price. Mainstream accessibility was gone. The simplicity of one-click installation from the Play Store was replaced with manual installation, side-loading, and technical troubleshooting. Millions of casual users who might have downloaded Termux out of curiosity simply moved on. What remained was a smaller, harder core of people who actually understood what they were doing. Google's restrictions actually revealed something about the power dynamic. Every time Google introduced a barrier, the community found a way around it. And each workaround required more technical sophistication, which filtered out casual users and left behind people who genuinely understood what they were doing. It was natural selection in software. By 2023, Termux was stronger than it had ever been. It had survived exile from the official App Store. It had survived the Phantom Process Killer. It had survived 4 years of Google actively trying to make it disappear. And it was still growing, still being downloaded, still being used by security researchers, system administrators, and people doing things Google would prefer they not do. The tool had become legendary in certain circles, precisely because it had survived every attack. The fact that Google was fighting so hard to kill it only proved how dangerous it actually was, which raised an obvious question. If it survived all this, what's actually stopping it from being as powerful as Kali Linux itself? Here's where reality hits. Mobile phones, despite their power, have fundamental physical limitations that desktop computers don't. The most obvious one is Wi-Fi. On a desktop computer with Kali Linux, you can plug in a wireless adapter that runs in monitor mode. This allows you to see all the network traffic in your vicinity. You can capture packets. You can analyze them. You can even inject your own packets back into the network. On a phone, that's impossible. The internal Wi-Fi chip's firmware is locked by the manufacturer. It doesn't support monitor mode. You can't inject packets. The hardware simply won't allow it. So what do people actually do? They take an external alpha network antenna, a high-powered wireless adapter, and connect it to their phone via a USB cable. It looks ridiculous. An expensive antenna dangling off the bottom of a sleek smartphone. But it works. There are other limitations. Thermal throttling. When a phone's processor gets too hot, it automatically slows down to cool itself. Run an intensive network scan for too long and your phone starts to choke. Battery life is finite. A laptop can run for hours. A phone might manage minutes of intense computational work before the battery dies. And there's the sheer processing power difference. A desktop CPU is built for sustained, heavy computation. A mobile processor is optimized for short bursts and efficiency. So no, a phone cannot do everything a laptop can do. The hardware eventually hits a ceiling. But here's what matters. The core capability is there. You can scan networks. You can identify vulnerabilities. You can deploy exploits. You can do 90% of what matters in a real-world attack scenario. And you can do it from a device that looks like you're checking your messages. That's the asymmetry that changes everything. Remember the lobby. The person sitting near the entrance looking like they're texting. The security cameras recording everything. The network defenses running perfectly. Why did none of it work? Because the threat didn't match the profile that security systems are built to detect. For decades, corporate security has been optimized around one assumption. If someone is attacking your network, they're going to look like they're attacking your network. They're going to have obvious equipment. They're going to have visible behavior. They're going to stand out. That assumption is dead, and it died the moment offensive capability became invisible. This is what Termux actually accomplished. Not raw power, not superior capability compared to Kali Linux. Kali is still more powerful in absolute terms. Kali still does things mobile can't do, but Kali requires you to be visible. You need a laptop. You need an obvious setup. You need to be noticed. Termux doesn't. Termux lets you blend in completely. The person in the lobby isn't a hacker. They're someone checking email. They're someone texting a friend. They're indistinguishable from everyone else in that space. And while they look like they're doing nothing, they're running network reconnaissance. They're identifying vulnerable systems. They're preparing exploits. They're doing all of it invisibly. This is the real disruption, not the tool itself. The invisibility. When the threat becomes impossible to see, when the attacker looks exactly like a normal person doing normal things, the entire defensive landscape has to change. All the security theater built around detecting suspicious equipment becomes worthless. All the behavioral profiling becomes useless. You can't see what you're not looking for. And the most dangerous part is this. The same tool that a legitimate security researcher uses to audit a network is identical to the tool a malicious actor uses to steal data. Same app, same capabilities, same invisibility. The democratization of offensive power came without a corresponding distribution of responsibility. Now anyone with a phone and basic technical knowledge can be a threat, and nobody will notice. We built an entire security infrastructure designed to catch visible threats. We optimized for detecting equipment, detecting behavior, detecting obvious signs of attack. And then we built a world where the most effective attacks require none of those things, where the attacker is perfectly camouflaged, where the weapon is invisible. That's the story of how Android, a platform designed to be safe, became a platform nobody knows how to defend against. That's the story of how the most powerful hacking tools in the world disappeared into everyone's pocket. And that's the question we're left with. If threats are invisible, what does security even mean anymore?